A warm welcome to all the viewers. Friends, this video is going to be quite special as I am going to show you how to use composite structural equation modeling module which is recently introduced in May 2026 by the developers of Jamovi. Now, this enables you to conduct PLS SEM, that is partial least square structural equation modeling, the way you used to execute the model in smartpls. So in case you don't have the access to the licensed version of smartpls, you don't know what to do, then Jamovi can help you do the analysis with formative as well as reflective constructs in the same model using this module composite structural equation modeling. How you can download it over here? Just simply go to modules and go to Jamovi library. Here you have to type composite SEM and here you have. So once you have this thing, you can install it, and when it asks for update, you can update it. Since I have already installed it, let us update it. So I have updated it. Now, what is this module about? This helps you to estimate, analyze, test and study linear and multi-group structural equation models. This module brings professional grade composite based structural equation modeling, also known as PLS SEM, or variance based structural equation modeling, having both formative and reflective constructs or just the formative constructs as well. To a user friendly graphical interface, the same feature which you can do in Smart PLS. First, we import the data. I go to new, open, and I import this CSV 305 datasheet that has 305 responses on customer satisfaction of the dining. So here I have case ID, occupation, gender, 0 denotes female, 1 denotes male, then FQ denotes food quality, having 4 reflective indicators you can see, FQ 1, 2, 3, 4, all marked on Likert 5-point scale. Then service quality having 4 indicators, again reflective, SQ1 to SQ4. Ambience AB1 to AB4, you see here. PF1 to PF4, that is price fairness. And then you have customer satisfaction, which is again marked on Likert 5-point scale, but this happens to be formative in nature. So I'm saying that these 4 indicators are proposed as formative indicators, lending their meaning to the latent variable, that is customer satisfaction. Now this is going to be our endogenous variable, that is formative in nature, and rest 4 of them are going to be exogenous or independent variables. Now how to do it? All these are on Likert scale, that is ordinals measurement scale. So all of them have been marked on ordinal. You see here, measure type is ordinal. We have the option of making it nominal, ordinal or continuous. So since they are ordinal, we mark them as ordinal, right? Now we go to composite structural equation modeling, click on composite SEM, and now we have to drag the latent variables over here. This is composite. Composite means formative. The latent variables which have formative indicators which are causing the latent variable, causal indicators, we call them formative, right? The arrow points from the indicators towards the latent variable in a composite. And here we have the reflective ones in latent. So we pick up FQ1 to FQ4, click on FQ1, press the shift button on your keyboard and now click on FQ4 and drag it like this and name it as FQ. So this is food quality. I named it as food quality like this. Okay. Next, add latent variable. Now I'm going to add service quality. Again, click SQ1, press shift button, click SQ4, drag the variables. And now I can name it as service quality. S quality like this. Now the third one, add latent ambience 1 to 4 like this, and I call this ambience. Then add latent variable, that's the fourth latent variable we have. All of these are exogenous variables, that is independent variables, right? Predictor variables. So PF1 to PF4, that is price fairness. I take them under latent variable 4 and name it as price fairness like this. So I've imported all the indicators of all four latent variables which are reflective in nature under this tab of latent. Now I need to put the composite in this bar. So composite 1, we just have one composite, that's the endogenous variable formed by four formative indicators CS1 to CS4. I select them and put them under composite like this, and I name it as customer satisfaction, right? This is the way I created. So now I've entered the data. You see the simultaneous calculations have started to happen over here on the right side. The execution of the data is started. Yeah, I can even put a categorical variable in here for multi-group analysis. Say I want to see the differences between males and females or three categories of occupation which I have. I can even do multi-group analysis. But for this video, we are concentrating on composite structural equation modeling, wherein we are trying to assess the effect of four reflective constructs upon the endogenous variable that is formed with four formative indicators, that's known as composite, right? I go to structural roles. Okay. Here in structural roles, I have to put these variables as they are, endogenous constructs and exogenous constructs. So endogenous is customer satisfaction, right? And exogenous is food quality and service quality, ambience and price fairness. I drag them over here like this. And now Jamovi is able to know that which are your exogenous independent variables and which is your dependent variable in this model, right? We have specified the measurement model and now we are checking on the estimation. Estimation using which type? You see here under model estimation we have PLS, we have GSCA, we have max variance. So we will go with PLS as we are going to imitate what the results we get in smart PLS. So go on with PLS, right? You want outer loadings of composite? You can click on outer loading of composite. This will help you to get outer loadings for the composite as well along with the outer weights. Though we generally assess the outer weights for their significance for formative construct, but in case they are not significant, we look at the outer loadings. So let us check on composite outer loadings as well. You can click on exact fit test. If you are checking on GSCA, we can ascertain that the model fits the data adequately if we get p-value greater than 0.05. But this is especially applicable if you choose in GSCA option instead of PLS. For if you are going in for PLS, don't need to click on exact fit test, right? In bootstrapping, we can go with 5000. This is to assess the significance of outer weights. So to assess the significance of outer weights, we do bootstrapping, right? So minimum prescribed is 5000. You have to go with 5000 bootstrap sample. And now see, we have defined all the things over here, right? We have defined all the things over here. Missing data, enable data cleaning, list-wise deletion. Since I don't have any missing values, I have checked on list-wise deletion. So there are no missing values in my data. That is already being checked, right? Now this directional paths, what is there, this we will define when we are assessing the structural model or doing the structural model assessment. First, we have to do the measurement model assessment, as you know, confirmatory factor analysis or measurement model assessment, and then we go to this structural model assessment. So first, let the software compute the values so that we do assess the measurement model, and then we go in for structural model assessment out of sample predictive power. We also check on R square, Q square, F square, as well as out of sample predictive power can be done as we do it in PLS predict. So this is the same thing which we do in PLS predict. Number of folds is 10 here. We usually keep it at 10 in smart PLS also. So you see friends, we got the results of composite structural equation modeling. First we got model structure summary, wherein we have all the four reflective latent variables which we had: food quality, service quality, ambience and price fairness, and their indicators. And we also have the composite, that is the formative, which is an endogenous variable, dependent variable, customer satisfaction, formed by four indicators, formative indicators, CS1 to CS4. Now, data cleaning summary. we adopted cleaning method used was list-wise deletion, but our data did not have any missing values. In case it had missing values, the computation would itself automatically delete those missing values respondents. Now, third is model information. Here you see number of observations 305, algorithm convergence achieved, yes, number of iterations 6, estimation method is PLS, inner weighting scheme is factorial, and disattenuate reflective measures is yes. So these are the settings which have been done. Disattenuation means observed indicators contain measurement error. So here we said disattenuate reflective measures. Yes. So we are telling the software, yes, we have the measurement error associated with observed indicators, and that is why we are doing structural equation modeling, because it accounts for those measurement errors while estimating the model, right? Now, degrees of freedom 155, SRMR and RMSE, both badness of fit of the model. The value should be less than 0.08 in both the cases. Ideally, for SRMR, we consider less than 0.06. But let me tell you one thing over here, since we are doing PLS structural equation modeling, these model fit indices are not prescribed to be reported, as they are much related to the conventional covariance based structural equation modeling which you do actually in AMOS. You can do CBSEM in Jamovi as well using this module you see over here, SEM. You go to SEM interactive and you can do that. But since we are using PLS estimation method, we are doing PLS SEM, a composite structural equation modeling where we have formative construct as well. So this model fit indices does not make that of sense. Now we have outer model of composites. So you see here in outer model of composites, composites here stands for formative construct, which was customer satisfaction, formed by four indicators CS1 to CS4. Why we have the loadings and weight as well? So first we assess the outer weights in case of formative constructs, even in PLS, even in smart PLS, right? So first we assess whether these weights are significant or not. The outer weight should be significant. Just in the case of reflective constructs, we assess whether each outer loading is above zero point 0.6 or sometimes above zero point 0.7, right? But for formative construct, that is composite, we assess the outer weights whether it is significant or not. So you see here CS1, the outer weight T value is 1.181, which is less than 1.96. So ideally it should be greater than 1.96 or lesser than minus 1.96. P value is also greater than 0.05, 0.237, which indicates its insignificance. Again, CS2 is again insignificant, CS3 is insignificant, but CS4 is significant, right? It is significant in forming the customer satisfaction formative construct. So that means this item, this indicator, formative indicator, contributes maximum to the formation of customer satisfaction as it is a formative construct, right? Because this is significant, less than 0.05, and even this value 2.922 is ahead of 1.96. So this is significant. You see here in 95% confidence interval, the zero does not lie in between. So that means significant. If the zero lies in between, as in the case of 1, 2, 3, the first three indicators CS1 to CS3, we say it is insignificant, as also shown to us by the p-value, right? So this is how you assess the outer weights. Now let us see the outer loadings. So we will see the factor loadings of all reflective constructs in our model, that is food quality formed by 4, service quality formed by 4 indicators, ambience formed by 4 indicators, and price fairness formed by 4 indicators. So these are the standardized estimate. Now when you do PLS SEMs, standardized estimates are the primary estimates. So the standard error which it calculates are also based on the standardized estimate. So when you divide standardized estimate by the standard error, in this case you get a t value. So you divide 0.749 by 0.0742, you will get 10.09. That is the t value. Now this is ahead of 1.96. So this is significant, and p value also shows it is significant. It is less than 0.05, and 0 does not come in between the lower confidence 95% confidence interval and upper 95% confidence interval, again signifying that it is significant. Now seeing the factor loading, Whether it's good to keep this indicator or not? Yes, it's quite good because it is above zero point 0.7. Prescribed is above zero point 0.7. So you see here from top to down, you look at them, all of them exhibit a factor loading of greater than zero point 0.7. So that is great enough. So it means the construct food quality is attributing to at least 50% of the variance in food quality 1 indicator, right? Because this value is greater than 0.708. So when it's greater than 0.708, you say that it's contributing to 50% of the variance in the indicator. So it's good to keep this indicator. This indicator makes a lot of sense, right? For this reflective construct, that is food quality. So that is how you assess and interpret it. Now let us see construct reliability. We have 4 of them in our model. Cronbach alpha, the value should be greater than zero point 0.7 to have a good reliability fit. And then you have average variance extracted, the value should be greater than zero point 0.5. So in all these 4 constructs, you see the value is greater than zero point 0.5, that establishes the convergent validity of the constructs, right? Second, we are looking at discriminant validity through HTMT values. So where you see the HTMT value should be less than 0.85. So all the values are less than 0.85. You see this matrix, they are less than 0.85. So we are good to go. Now we will check the variance inflation factor for mode B. Mode B means for composites, for formative construct. Since CS customer satisfaction is a formative construct, we have to check the VIF values, that is the outer VIF values, they should be less than 3.3. So in this case, you see that all of them are less than 3.3. Only CS1 is more than 3.3. Here you see that although VIF values are well in the acceptable range, that means there is no issue of multicollinearity. But if there is no multicollinearity concern, then why these outer weights which we got are insignificant? These outer weights are insignificant. That means these indicators correlate with each other and they are basically of reflective in nature. So just giving you an example that why it has happened so. The reason could be that they are reflective indicators. They are not truly formative indicators which depict different meanings. Formative indicators mean they give different meanings. They ask in different aspect of the construct to form customer satisfaction, right? So in case this thing happens, this flaw can happen if these indicators are reflective in nature instead of formative as you have taken in the model. Since this is just a demo, I'm showing you a practical session on how to conduct composite structural equation modeling. But along with that, I'm also showing you that why this thing happened, why the outer weights were insignificant. And in case these are insignificant, then what to do? The rule says that we should look in for outer loading. So seeing at the outer loading, they are all good. They are all above 0.7. You see 0.914, 0.866, 0.699, 0.844. They are all above 0.7. So why does this happen? This happens because they are actually reflective indicators in their nature, not formative as we have taken it in the model. But still we are learning how to see that how to do composite structural equation modeling using Jamovi. Now let us see the construct correlations. So when you see the construct correlations, they should neither be too low nor be too high. So in this case, we see that all of the construct correlations are significant. The p value being less than 0.05 and the t value is greater than plus 1.96 or lesser than minus 1.96, which is the threshold. All of them are greater than plus 1.96 in this case. And the correlation they exhibit within each other, for example, food quality versus service quality 0.404, that's a medium correlation which it exhibits, right? And when I see 0.292, that's a weak correlation it exhibits. The highest amount of correlation is exhibited between service quality and ambience, so that is a strong relationship, 0.588. We can also confer one thing from this construct correlations table, that the correlations, the relationships between our involved constructs is not by chance. It is actually happening as we have got the significance values of the correlation. The correlations are quite significant. So it is not by chance. So if it would have been by chance, we are having a scope of type 1 error. So since they are significant, we are out of the scope of type 1 error in this case, right? Now let us see how to assess the structural model. This was measurement model assessment. Now I'll show you how to assess the structural model. For structural directional relationships, we have to specify over here. See, endogenous is specified as customer satisfaction. Now exogenous, that is independent variables, one by one we take it over here. Food quality, service quality, ambience, and price fairness. Now you see the software automatically starts its work and starts computing and doing the calculations. In case you want predictive validity assessment also, just like we do it in smart PLS, through PLS predict, we can check on out of sample predictive power and keep the number of folds on 10 and we'll get the results. So the software will take some time depending upon the processor of your PC, and it will give you the results in the meanwhile. We got these results. So what to look in for? First, we will look in for the directional relationships, that is the path coefficients. So you see here, we directly come to inner model, that is structural relationships, right? This is to be assessed for structural model assessment, which is the second part in structural equation modeling. Here you see the predictor food quality and the outcome is customer satisfaction. Customer satisfaction, which is a formative composite construct, and predictor is reflective construct, right? The path coefficient beta, that is standardized path coefficient, is 0.2136. When we divide 0.2136 by standard error, we get the t value that comes out to be 2.042. That is well above 1.96. So it is significant. You see p value is less than 0.05 and there is no zero lying in between the lower and upper confidence interval limit. Second one, service quality to customer satisfaction. It's insignificant. P value is greater than 0.05. Even you can see it from the t value. It's not more than 1.96. R square is 0.253. So what is this adjusted R square? You get adjusted R square also. Adjusted R square means when you remove the ineffective or insignificant independent variables, predictive variables from the model, then what R square you get? You get 0.243. And when you include them, for an instance, you are including service quality effect on customer satisfaction, which is an insignificant effect, you get 0.253. So adjusted R square is a better measure to check. This is coefficient of determination, which determines how much variation in the dependent variable, that is customer satisfaction, is accounted for by the combination of all four predictor variables, right? So we see here 24.3% variance in the dependent variable is accounted for by the predictor variables. We have four predictor variables, right? So here we can check ambience on customer satisfaction. Again, it is significant, less than 0.05. And price fairness on customer satisfaction is more than, the p value is more than 0.05, hence it is insignificant, right? Even the t value says the same thing. So this is how you can do a structural model assessment quite conveniently and quite easily using Jamovi software. I hope the video was quite informative and useful for you, and you will definitely share it with your friends and faculty colleagues. See you next time with some more informative content.